Hello, my name is Scott from McClelland Air Conditioning, and today we're here to perform an evaluation on the heating and cooling needs of this home. We'd like to do this before we install a system, so we make sure we get it right the first time and it works properly. So what we're going to do today is walk around the house, take some pictures, do a load calculation so we understand what the true need of the home is. We'll ask questions and find out what the homeowner needs in specific rooms for their independent or their particular needs inside the home. The first thing I like to do when I arrive at a home is take a picture of the front of the home. This does two things. One is I keep it in the file so I understand, keep that house tied to the whole file, but it also gives me an idea on what the general construction and age of the home is, so we get the insulation values of the walls and the windows and things like that. So let me take that picture first and then we'll go inside the house. Okay, let's go inside and see what we have. When I start my drawings, I like to always come in and go in one direction so I can walk basically in a circle around the house and I don't miss any rooms. So as I came in the door, I'm going to start over here to the left, and I run into the first room off the living room is the kitchen. So I make a basic draw plan, draw the footprint of it, and then I draw in any windows that we might have, because that's got to figure into my load calculation. This room has a lot of windows, and it appears they're all single pane, the old crank out style. So what I'm going to want to do is make a note of that, because those windows will play into the effective amount of heat gain we have in the house. Now I take my laser out, and because of the way the room is laid out, I'm going to take my laser and put it up here, and I can get my distance across the room, like so. This room measures 19 feet and 1 inch. We have a laundry room off the back of the kitchen here, between the kitchen and the garage. I'm not necessarily concerned with the garage, but I do want to consider this room because it is part of the occupied space. So as I do this, again, I'm going to measure both ways. Make notations of the doors. That one is 6 by 19. Okay, as we continue to make our drawing of the footprint of the home, we're going to keep measuring out rooms as we go along. We're going to stop and measure a window here in a second. We'll measure each window as we go through the house, but while I'm here, let me get the measurement of this room. We have 15 by 25. So as we enter the hall, I see the thermostats here on the left, so I'm going to make a note of that as I draw out my footprint, and I have that location. First room is a bedroom. Down here, as we move on, we go into the bedroom, we look. Looks like it's going to be a workout room. We may want to take that into consideration and think we're going to need some extra air because of the added heat that's caused by the exercise. So as I do this, I'm going to make my notes on my windows, and I'm going to get my footprint of the house. Okay, as part of the overall evaluation of the home, we need to look in the attic. We're going to check insulation, see what the ducting looks like, structure, things like that that may have an effect on the heating and cooling load of the home. So I'm going to go up in the attic, take a look, and we'll see where we're at. After evaluating the attic, we find that the insulation is adequate. It could use a little bit more. The ducting appears to be in good shape, and the structure is strong enough to hold the unit on the roof. Now we need to go up on the roof and get the model and serial number off the existing so we can compare it and see what the load comes out to. Okay, so as we come up to the unit, I just like to take a few pictures of the unit so I can get a general overall condition of not only the unit, but the way the current one is installed and the condition of the roof. As I'm walking around this unit, I notice it's a downflow curve. That means there's no roof elbow. The ducts go straight out of the bottom. The condensate is done fairly well. Has a fused electrical disconnect here on the side of the unit. And we want to make sure that that's adequately sized for the equipment. So as I pull this out, I'm going to notice that this is a 30 amp fuse, and we'll step over here and see what size the unit actually requires. The gas line is run over the roof for a little bit of a distance. That's not bad. It'll work fine for us. As I look at the unit, I'm going to take a picture of the identification plate, and I'm going to keep that for my records. It doesn't have a whole lot of bearing on what we're doing as far as new. We want to make sure that we've got the proper size when we're done. What this is going to do is help us evaluate what their energy bills have been compared to what they will be. First thing we want to do at the electric panel is we want to identify the breaker that goes to the air conditioning unit. I see one here that's 30 amp, but it's marked the dryer and the wash machine, and then we have a 40 amp. There's no other heavy-duty appliances in the house, so for the time being, I'm going to say that that is our AC unit, and we're going to go from there. But while I'm here, I'm going to take a picture so I have record of it, and then we can open it up and find out. Okay, as we move on and we keep making a floor plan of the house, we keep moving, make the next wall, which is like so. Again, you see the window. We're going to make our little outcropping here for the laundry room kitchen, which is 25 feet. and then we're going to move on. So as we look at the floor plan of the house as it's completed, it shows we have 1,475 square feet. Now we're going to go and look at what the real benefit of this program is, and that is the load on the house. That's going to tell us the actual size of the air conditioning unit that we're going to need. So now we're going to go over and we're going to see what the load calc on the house is. And again, it shows us right here, we have 3.7 tons. It shows us how much energy loss we have just through the duct system alone. That's the single largest amount of energy loss in this home. So by putting a tight duct system in the home, it will make it much more efficient. Plus it will also cut down on any impurities coming through the duct system. Pollen, dust, auto exhaust, things from outside don't get drawn into the house through the heating and cooling system. Then we're going to look at walls and windows. Some areas that might benefit upgrades versus putting the money in the heating and air conditioning, because overall we want to look out for what's best for the homeowner. And with that, we're going to say we have a 3.5 ton duct system, or a 3.5 ton cooling system is required. The heating is not going to be a problem. We have a package unit on the roof which has heating and cooling built into it. All the 3.5 ton package units are going to have adequate heating for this house. So we're also going to look at staging heating and cooling. We'll have high-low heating so we're not overheating or overcooling the home. Okay, so now that we've completed the evaluation of the home, what we're going to recommend is a higher efficiency heating and cooling system than they have. We're going to seal the duct system to improve air quality inside the home and comfort, cut down on drafts, things like that. There's different systems. Everybody does not need the same system, so we try to build the system specifically for the customer. So if you would like a free complimentary evaluation of your heating and cooling system, please call us at McClelland Air Conditioning, and we will be glad to take care of that for you.